Students, today we discuss about some of the questions from D and F block elements and which are appeared in the previous entrance exams and also which are very important. Let us see the first question and see in which oxidation states copper and iron undergo disproportionation in aqueous solution. Coming to the first option, either you consider copper plus 2 and Au plus 2. They are not actually undergoing any change or any disproportionate any reaction in the aqueous solution. Coming to plus 3 is not existing for this particular copper and Au. Coming to plus 4, yes, for copper and iron also plus 4 is not stable, plus 4 doesn't exist at all. But coming to plus 1, copper and iron doesn't exist in aqueous solution, undergo disproportionation. What is disproportionation? You might be knowing this, the simultaneous oxidation and reduction of an element in a particular chemical reaction. Now, simultaneous oxidation and reduction. In what way? This copper plus 1 and Au plus 1 undergoing simultaneous oxidation and reduction. Let us see. According to this particular equation, look here, 2Cu plus 1 you take. This undergoing this disproportionation, it is easily converting into copper plus 2 and copper in aqueous solution. How can you say that this copper plus 1 doesn't exist in aqueous solution? Equilibrium constant you write for this, then it will be copper plus 2 and copper plus 1 square. This particular reaction equilibrium constant value coming to be 1.6 into 10 to the power of 6. See, such a very big value, 1.6 into the power of 6 means what? Copper plus 2 concentration is this many times greater than copper plus 1. In comparison to this particular copper plus 1, the concentration of copper plus 2 is very high. Therefore, we are concluding that copper plus 1 doesn't exist. If it exists, very trace amounts it may be existing in the aqueous solution, easily undergoing oxidation to copper plus 2. Similarly, you talk about Au also. Consider in the case of Au, suppose you consider Au plus 3 you take. What I am saying, Au plus 1 is said, no, right, Au plus 1 only we write. Au plus 1, 3 Au plus 1, similar way, take it. This is undergoing oxidation, plus 1 undergoing oxidation to plus 3, and again this is what 2 Au. Au plus 3 to Au. Let us write this particular equilibrium constant for this K. Au plus 3 and followed by Au plus 1 cube. This particular equation equilibrium constant value is found to be 1 into 10 to the power of 10. See, imagine it's a very big value, means in aqueous solution Au plus 3 concentration is 1 into 10 to the power of 10. We can say it is millions and billions in comparison to Au plus 1. Au plus 1. Therefore, here copper plus 2 concentration and Au plus 3 concentration both are actually many more times greater than either you take copper plus 1 concentration, Au plus 1 concentration in aqueous solution. From these two equilibrium constant values, we can conclude that copper plus 1 and Au plus 1 are not existing in aqueous solution, because in the case of copper plus 2 is stable in aqueous solution, and in the case of Au plus 3 is stable in the aqueous solution. Therefore, copper plus 1 and Au plus 1 undergoing disproportionation in aqueous solution. We can say that they are not existing in aqueous solution. Therefore, option D is correct for this particular first question. See question number 2. Nobility from copper to iron. Option A is increases and B is what? Decreases. C is what? Increase and decrease. Fourth option is what? D, none. Nobility from copper to iron actually increases. From top to the bottom, the mass number is increasing, copper to Ag, Ag to Ae. The mass number increasing for this particular currency metals, copper, Ag, Au, their nobility is increasing. Then particular Au also often we call noble metal. Why the top to the bottom this particular copper to Ag, Ag to Au increasing. And the mass number is increasing, therefore their nobility, reactivity decrease and nobility increase. Therefore, copper to Au nobility is increasing. It may be due to, we can consider in the case of 5D series supplement, it may be due to lanthanide contraction effect and lanthanide, presence of lanthanide element. All these are the reasons for this particular copper to Ag, Ag to Au nobility increasing, and Au also commonly called as what a noble metal. In this particular case, answer is what A, and answer is what A for the second question. Third question, which of the following the correct sequence of stability of halide complex of Ag plus and copper plus? And option A is I minus less than Br minus Cl minus F minus, and option B is Br minus equal to Cl minus less than I minus and F minus, or this option C is I minus more than Br minus and more than Cl minus more than F minus. Answer this option D is none. But in this case, once you consider Ag plus and copper plus, these two are behaving in different way from the other metals. For all other metals, for halide complexes, normal order is actually followed. What normal order is actually followed? I minus, the iodide complexes are less stable than bromide and chloride and fluoride for all other normal metals. But in the case of this particular Ag plus and copper plus, you have to consider another concept. In the case of Ag plus and copper plus, these two are actually heavier D block elements, not heavier D block elements. Because of this particular reason, Ag plus and copper plus, these two metals are coming under what soft acids. Ag plus and again copper plus coming under soft acids. Once a soft acid is there, soft acid always prefers to react with a soft base only. Consider F minus is what hard base, but I minus is what a soft base. There is always a combination between hard and soft. As Ag plus, copper plus are soft acids, these two are easily reacting with a soft base like I minus and forming highly stable complex. A product produced by soft combination or hard combination is found to be more stable. Because of this particular reason, the option C is correct here. So answer is what C option. Which of the following group is currency metals? You might be knowing this. In the case of D block elements, copper, Ag, Au, these are generally used in the manufacture, preparation of different types of coins. In our olden days also, these particular three metals are much more involved in the preparation of these particular different types of coins. Therefore, these metals are commonly known as copper, Ag, Au, commonly known as currency metals or coinage metals. So in this particular, A bit is what copper, Ag, platinum given, B option copper, Ag, iridium given, and C option copper, Ag, palladium. But copper, Ag, Au only much more used in the manufacture or preparation of coins. Therefore, for fourth question, option D is the answer. So answer is what D. Coming to fifth question, on adding KH solution in excess to a solution of copper sulfate, we get a precipitate P and mother liquor M. Select the pair. Option A is what? P is cupric iodide, M is I2 solution given, and B option is, and P is Cu2I2 cuprous iodide, and M is what? I2 solution, and option C is P is Cu2I2, M is Ki3 solution, and option D is what? P is Cu I2, M is Ki3 solution. In this particular case, according to the equation, this generally we come across this particular equation, the volumetric analysis. In the volumetric analysis, this particular equation comes, this particular concept comes in the volumetric analysis, but is related to what? D block elements. Now, what the way this particular K is reacting? Look the board, 4Ki to CuSO4, the reaction between these. Now you are getting here Cu2I2, a precipitate you are getting, followed by 2K2SO4 plus I2 you are getting. This is the reaction between potassium iodide and copper sulfate. as the I2 is produced, yes, I2 is produced in the first equation. See, this particular I2 freely react with again little more amount of Ki, giving rise to a complex Ki3, or you can write this particular as iodide ion, triiodide ion, complex ion or complex compound. Therefore, wherever a complex is produced, Ki converting into Ki3 complex, then Ki3 is actually soluble in water. But this particular Cu2 is what? Precipitate. Therefore, this particular options, the C option you see, P is what? Cu2I2 precipitate, and Ki3 is what? Soluble in water I am saying. Therefore, for this particular question, option C the answer. It is very important also to remember this question is appearing in different exams. Right, answer C the correct answer here. Coming to sixth, fulminating gold is. See, some of the chemical formula you have to remember. Such questions also appearing in the entrance exams. Right, fulminating gold. The answer option A is what? AuNH2 is said. Option B is AuNH double bond NH2, and option C is AuNH2 double bond NH2, and option D is what? Au double bond NH single bond NH2. Among all these, what is fulminating gold? How we get fulminating gold? I am showing how you get fulminating gold. Auric chloride on reaction with ammonia, they are getting this particular fulminating gold, NH2 double bond NH plus 3HCl. This is what of fulminating gold. Fulminating gold. So here for sixth question, option D the answer. So answer is D. But this you have to remember the chemical formula of this particular the fulminating gold. Some of the chemical formula you have to remember because such type of questions also appearing in different entrance exams. Coming to the seventh question, in 3 tubes marked A, B, C solutions of salts, one is zinc, cadmium and mercury, were kept separate. To these excess of NaOH was added, the tubes will now contain. The tubes will now contain. So in 3 test tubes, 3 different solutions are taken, zinc, cadmium and mercury. To this you are adding sodium hydroxide. Then what is happening to these particular 3 solutions? Remember, see, zinc clear solution I said, zinc clear solution, consider sodium hydroxide, what you are getting, well known to you, this is actually Na2, ZnO2, soluble. This is soluble sodium zincate you are getting. Similarly, you talk about this particular cadmium. Now you add this particular sodium hydroxide to this, sodium hydroxide. Then you are getting what? Cadmium hydroxide, precipitate you are getting, which is insoluble in water. Now you talk about mercury. This also reacts with sodium hydroxide. Yes, you are getting first mercury hydroxide. Mercury hydroxide ultimately decomposing to produce what? Mercuric oxide. First, mercuric hydroxide you are getting. This hydroxide ultimately decomposed to produce mercuric oxide. Therefore, for zinc, a clear solution. For cadmium hydroxide precipitate. For mercury, at the end you are getting mercuric oxide. Therefore, for this particular 7th question, option B is the answer. Coming to 8th question, which of the following possesses same number of unpaired electrons as in nickel plus 4? Option A, vanadium. Option B, chromium. Option C, Mn plus 3. And option D, Fe plus 3. First, you have to check it according to the question given, nickel plus 4. Nickel plus 4, how many unpaired electrons is there in nickel plus 4? I have given already to you easy way of locating or saying the number of unpaired electrons. Nickel, it is what? 28. Put a line in the middle, then it will be D8S2, 28 D8S2. For nickel plus 4, look here, how many electrons lost? 4. So nickel plus 4, it is D6. Yes, D6 means what? 4 unpaired electrons. 4 unpaired electrons. Coming to option A, suppose you talk about A, simply given as what? Vanadium. Vanadium, what is the electronic configuration? Yes, it is 23. 23 means what? D3S2, 3 unpaired electrons are there. No, it is not our answer. Coming to option B, chromium. Well known to you, chromium electronic configuration D5S1. Look here, how many unpaired electrons are there? 5 plus 1, 6. No, it is not our answer. 6 electrons are there. Coming to option C, Mn plus 3. Given as what? Mn plus 3. This you know, M1, Mn, it is what? 25. 25 means what? D5S2. Look here, how many electrons lost? Mn plus 3. 3 electrons lost. Therefore, it is what? 2 electrons from S, 1 electron from D. So, remaining configuration of Mn plus 3 is what? D4. Then, option C is the correct answer here. Option C, answer is what? C. But come to this particular option D also, let us check. Now, Fe plus 3 is given. You know, of Fe plus 3 means what? D5 configuration carrying 5 unpaired electrons. So, nickel plus 4 carrying 4 unpaired electrons. Mn plus 3 carrying 4 unpaired electrons. So, for this particular 8th question, that is option C the correct answer. Coming to the question number 9, which of the following pairs have the same number of unpaired electrons? Same number of unpaired electrons in each pair, you have to check it. Coming to the option 1, Mn and chromium. Yes. Coming to option A, Mn and chromium are given. Mn actually, you know, it is D5 S2 and chromium it is what? D5 S1. It is carrying what? 5 unpaired electrons. It is carrying 6 unpaired electrons. It is not our answer. Coming to option B, Mn plus 2. Mn plus 2. Mn plus 2 means again D5 configuration. Mn plus 5 plus 2. Chromium plus 3 means D3 remaining. See, 5 unpaired electrons and 3 unpaired electrons. So, it is not our answer. Coming to C, Fe plus 2 and nickel plus 4. Fe plus 2 means, Fe means what? 26. It was D6S2. Fe plus 2 means remaining is what? D6. D6 how many unpaired electrons? 4. Next, nickel plus 4. Coming to nickel plus 4. Nickel is what? D8S2. And plus 4 means then it is what? D6. See, both of these carrying electronic configuration D6. In D6 case, both are having same number of unpaired electrons. Therefore, answer is what? C here. Option C is what answer. Coming to D, still I will explain why not D. Coming to chromium plus 1, yes, you know, chromium plus 1 means what? D5 and unpaired electrons are 5. Fe plus 2 already shown here, D6, 4. So, chromium plus 1 is carrying 5 unpaired electrons. Fe plus 2 is carrying 4 unpaired electrons. Therefore, only the answer, this option C, the correct answer, carrying both 4 unpaired electrons. Coming to question number 10, which of the following have unequal number of unpaired electrons? Unequal number of unpaired electrons. Option A, nickel and vanadium. See option A if you consider nickel, vanadium. Yes, nickel electronic configuration D8. This is what? D3. D8 means what? 2 unpaired electrons. C, 5 unpaired electrons. And 6th is paired, 7th is paired, 8th is paired, 2 unpaired electrons. So, it's particular nickel is carrying 2 and vanadium is carrying what? 3? No, it is carrying what? Unequal number of unpaired electrons, nickel and vanadium. Coming to option B, this is what? Iron. Iron, what is the atomic number? 26. 26 means what? D6, D6S2 and chromium plus 2. Chromium plus 2, chromium actually D5S1 plus 2 means what? D4. See, D6 4 unpaired and D4 4 unpaired, carrying what? Equal. Coming to C, option C, chromium plus 1. Chromium plus 1 means D5, it is what? 5 unpaired electrons. Fe plus 3 also D5, both of these are carrying same number of unpaired electrons, so 5. So, answer option A in only nickel and vanadium carrying different number of unequal number of unpaired electrons. So, for this particular, this 10th question, option A is correct answer. Therefore, option A is the correct answer. Next is let us see next 11th question. 11th. Which of the following have same magnetic moment? How you say which are having the same magnetic moment? First you have to check the number of unpaired electrons. Based on number of unpaired electrons only, we can say which is having either unequal or equal or same or not the same and all we can discuss. Now coming to the option A in this, yes, chromium and iron is given. Chromium configuration C, D5S1, iron is what? D6S2. D6S2. Yes, 6 unpaired electrons and again 4 unpaired electrons. It is not our answer. Coming to what? Option B. Chromium plus 1, Fe plus 2. Chromium plus 1 is what? D5 and Fe plus 2 means D6S0. So it is actually 5 unpaired electrons, here 4 unpaired electrons. So answer option B is also not correct. Coming to option C. Option C. Fe plus 3, chromium plus 1 is given. Fe plus 3, you know, D5, chromium plus 1, D5. So both are having same number of unpaired electrons. Yes, Fe plus 3, chromium plus 1. The answer is what? Option C, and carrying same number of unpaired electrons, their magnetic moment is same. Now let me show this particular option D. Why not the option D? Nickel plus 4, yes, nickel plus 4 is D6. Vanadium has given, vanadium is what? D3. It is carrying 4 unpaired, it is carrying 3 unpaired. Therefore, this is not our answer. This option C, let me say answer C is the correct for 11th question. Right. Coming to the question number 12, osmium, indium, platinum are together known as. Generally in the D block elements, these 6 elements already given to you: ruthenium, rhodium, palladium, osmium, iridium, platinum. These 6 elements together generally known as platinum metals. Platinum metals. Platinum metals. But in these particular 6, these are actually lighter, having less mass. Therefore, ruthenium, rhodium, palladium are known as lighter platinum metals. And osmium, indium, platinum are known as heavier platinum metals. Therefore, option A is given as what? Lighter platinum metals. These are lighter, but these are what? Heavier platinum. Therefore, option B is the correct answer. So, answer B is this correct answer here. Answer B. Osmium, iridium, platinum are known as platinum metals only, but these are heavier, therefore commonly known as heavier platinum metals. But the first 3 we call them as what? Lighter platinum metal. All together what to call? Yes, platinum metals. Lighter, lighter platinum, heavier, heavier platinum metals. Coming to the question number 13, given as what? Titanium plus 4, chromium plus 1, Fe plus 4, nickel plus 2. The increasing order of number of unpaired electrons. If you see all the options A, B, C, D, you will be getting confused. Don't see the options first. First to see the question and what are the number of unpaired electrons in each. First let us calculate ourselves. Then you go for the answers. It will be easy for you. Without any confusion you can answer it. So first let us see titanium plus 4. First to do the answer. Titanium plus 4, chromium plus 1, nickel plus 2, chromium plus 1, Fe plus 4. Next one is Fe plus 4 and you take nickel plus 2. Nickel plus 2. See titanium, you know, 22. I said many times the second number in the configuration D2S2. Right, titanium plus 4 means, yes, you can easily understand 0, no unpaired electron at all. Coming to this particular chromium plus 1, you know 24 and configuration also well known to you. Yes, D5S1 given as plus 1. Then it will be what? D5, how many unpaired electrons? 5. Coming to Fe plus 4, yes, 26. 26 means what? D6S2 plus 4 means remaining is what? 2 and 2 electrons lost. Therefore, what? 4 coming to be this Fe plus 4, it is D4, 4 unpaired. Coming to nickel plus 2, yes, it is 28. 28 means D8S2 plus 2 means D8 only. It is carrying what? 2. See, these are the number of unpaired electrons. Now we can check the options now. See, this particular titanium is having less than nickel plus 2. Nickel plus 2 is having less than Fe plus 4. Fe plus 4 is having less than chromium plus 1. Don't see the answers. Little bit confused the answers are there. Don't be confused. First see the question, do yourself, calculate the number of unpaired electrons, go for the answers now. So answer option B is the correct here. Titanium plus 4 less than nickel plus 2 less than Fe plus 4 and chromium plus 1. This is the way you have to do such a question appear in the entrance exam. Here answer B the correct. Coming to the question number 14. Which of the following unlikely to exist? See, when such a question appears, a metal cannot form a compound more than its possible oxidation number. More than its possible oxidation number. See the option C, we do S4 taken thrice. That means what? Vanadium is what? Option A you are taking. Vanadium is what? Plus 3 oxidation number. Plus 3. Yes, possible. For vanadium plus 3 is possible. Coming to option B is given as what? VO3. VO3 means vanadium is coming to be plus 6. Maximum oxidation number of vanadium is only plus 5 because its electronic configuration is what? D3S2. It can lose a total of 5 electrons. It can come to a maximum oxidation number of plus 5. But in the case of VO3 it is given as what? Plus 6 oxidation number. No, for vanadium plus 6 oxidation number is not possible at all. Coming to the option C, it is now VOSO4. O is minus 2 and SO4 is also minus 2. Total minus 4 charges. Then vanadium coming to be here plus 4. Yes, possible. Coming to option D, KVO3. In KVO3, K is plus 1. Actually, negative charges are 6 because 3 oxygens, each is minus 2. Total negative charges are 6. Out of 6 charges, 1 K is there, it is plus, vanadium plus 5. So in the option D also, you are having vanadium oxidation number plus 5. This is also possible. Wherever the metal oxidation number is beyond its expected oxidation number, beyond its group number, then that particular compound is not possible. In this particular answers, option B, vanadium is exhibiting plus 6 oxidation number, which is not possible for vanadium. So option B is the correct answer. This is what answer B is the correct answer. Next question. Question number 15. Which of the following is least covalent? Whenever such a question appears, see among the given options already given in oxidation numbers, discussing about oxidation number in D block elements. A metal with different oxidation numbers are given. Lowest oxidation number you take, lowest oxidation number, that is what more basic or ionic I said. Wherever highest oxidation number is there, that you have to consider what more covalent or more acidic. Lowest is basic or ionic. Highest is covalent or acidic. Which of the following is least covalent? Least covalent means more ionic. More ionic means among the given options, consider which is having lower oxidation state for vanadium. Coming to option A, right? VCl2, simply it is vanadium is plus 2. Option B, VCl3, vanadium is what? Plus 3 oxidation number. Coming to option C, VCl4, you are clearly looking, it is what? Plus 4. And coming to the next one, VOCl3, oxygen is what? Minus 2, 3 chlorions minus 3, total coming to what? Minus 5. Therefore, vanadium it is what? Plus 5. Then, what I given? Least covalent. Least covalent means more ionic. More ionic means least oxidation number we have to choose. Therefore, answer A is the correct answer. Answer A is the correct answer here. Coming to the next question, 16. The crystal lattice of nickel is. After completing entire D block elements, I given all the 3D, 4D, 5D, I put on the board. And these particular 30 D block elements are having different types of metallic lattices, HCP, FCC, BCC like that. Remembering is difficult. So I made it an easy way how to remember. I classified all the 30 elements into this particular different metallic lattices, SCP or CCP, FCC, BCC. But you have to remember there is no much explanation is required for this. In the case of nickel, I have given clearly in the class notes, that is B is the correct option here. Nickel is having CCP, cubic close packing, or also known as face-centered cubic lattice. Nickel metallic lattice is answer option B, that is CCP. So here this particular question be the correct option. Right. Coming to the question number 17th, which of the following is more acidic? See, one more question, the same type of question is repeated. Which of the following is more acidic? What I given the concept say? Among the given options, you see the metal in which it is having highest oxidation number, more acidic is said. Lower the oxidation number I said, more basic or ionic. Higher the oxidation number I said, more covalent or acidic acid. Coming to option A, FeO plus 2. Coming to B, Fe2O3, iron oxidation number is only plus 3. Option C, FeO3 plus 6. And D, FeO2, then it is what? Plus 4. We require more acidic, greater the oxidation number you have to choose given the options. So here option C is the correct answer, then it will be C answer. Question number 18, which of the following is highly acidic oxide? See, again more or less identical question. These questions are, this type of questions are appearing in different entrance exams. So I given many such questions, and I given the concept how to identify the acidic oxide or the basic oxide. Which of the following is highly acidic oxide? Among the options, choose which is having highest oxidation number. Yes, coming to A, option A, CrO2 plus 4. Option B, Cr2O3, oxidation number you know plus 3. Option C, CrO3, yes, plus 6. And option D, it is CrO only given plus 2. Which of the following is highly acidic? Then choose the metal with the greater oxidation number. So in this particular case, option C is the answer. This is the answer. Question number 19, rust is a mixture of. Rust is a mixture of, yes, frequently you see here and there wherever iron is exposed to moist air. Without any dry air, it is not undergoing rusting, but in the moist air, the rainy season you see, easily it is getting rusted. Rust is actually a mixture of ferric oxide and ferric hydroxide. Ferric oxide and ferric hydroxide. A is given as what? FeO and Fe2O3. B, option B is given as what? That ferric hydroxide and ferric oxide. Ferric hydroxide and ferric oxide. And option C is given FeO2 and Fe. And D is given as what? None. So here what I said, rust is a mixture of ferric oxide and ferric hydroxide. Therefore here the answer option B is the correct answer. This you remember the exact composition of this particular rust. It is a mixture of ferric oxide and ferric hydroxide. See, coming to the question number 20. Rusting of iron is a phenomenon. Generally we feel the rusting of iron given as what? A, chemical process. B, electrochemical process. C, physical process. D is given as what? None. D is given as none. See, generally we feel this may be a chemical process. No. In absence of moisture, in absence of H plus ions, this rusting of iron is not taking place. Therefore, in presence of H plus ions only, this rusting takes place. Therefore, this particular rusting of iron, remember, this is only electrochemical process. Electrochemical process. Electrochemical process. Here, answer is for this question is what? Option B the answer. Rusting of iron, remember as electrochemical process. Generally, we feel it may be chemical process. No, it is electrochemical process because it is taking place in presence of formation of H plus ions. So option B the correct one. Coming to the question number 21. Which of the following ions show maximum magnetic moment? See, magnetic moment wherever comes. Check it. Which ion is carrying more number of unpaired electrons? Coming to option A, what is given? Fe plus 2. Yes, Fe plus 2 means D6 configuration, 4 unpaired electrons. Coming to option B, Fe plus 3 is given. Fe plus 3 ferric ion, yes, D5, 5 unpaired electrons. Option C, heat nickel plus 2. There is what? D8. D8 electronic configuration, only 2 unpaired electrons. Mn plus 4. Mn plus 4 is actually D3 configuration, 3 unpaired electrons. Check it. What I said, you want to see the magnetic moment, you have to check the number of unpaired electrons. Among the given options, this particular Fe plus 3 is D5 configuration, carrying more number of unpaired electrons, that will be exhibiting highest magnetic moment. So option B is the correct. Coming to the question number 22, which of the following compounds of titanium is unlikely to exist? Wherever such question appears, see the metal is titanium. Titanium maximum oxidation number coming to be plus 4. If you want to see among A, B, C, D options in which the oxidation number is more than plus 4, that particular compound of titanium is not existing. Coming to option A, simply as given TiCl2, yes, it is plus 2 oxidation number, exists. Coming to option B, TiCl4 is given, yes, plus 4, existing. Coming to option C, it is TiF8 minus 3. Inside this particular bracket you are looking 8 negative charges, minus 3. Therefore, titanium coming to be plus 5 oxidation number. And again, option D you take. TiF6 minus 2. Inside is minus 6 charges, 2 charges are existing, coming to be again plus 4. But I said, titanium maximum oxidation number possible is only plus 4. But in the case of option C, it is coming to be 5. Therefore, this is the correct answer. For this, answer is C. Coming to the question number 23. 23. Which of the following is the correct increasing order of unpaired electrons? Yes, before this also this type of question has come. Wherever such question appears, take the ions first. See the unpaired electrons in the following. Then you go for the options. Directly you are going and checking the answers. There is a little bit confusion. What are given there? Scandium plus 2, vanadium plus 2, titanium plus 2, chromium plus 2. These are the 4 ions. What are given? Check it. Scandium plus 2 is given, titanium plus 2 is given, vanadium plus 2, chromium plus 2. These are the ions, no? All the 4 ions are written on the board. Now, scandium plus 2 means, number of unpaired electrons 1. How you say? D1S2. Plus 2 means what? D1. Only 1 unpaired electron. Coming to this particular titanium plus 2 we check. 22. D2S2. Plus 2 means it is 2 unpaired electrons. And again, vanadium plus 3. 23. D3S2 plus 2 means what? 3 unpaired electrons. Coming to this particular chromium, D5S1 plus 2 means 2 electrons plus 4. So these are the number of unpaired electrons among these particular ions. Then now you go for the option, which option is correct. So scandium plus 1 plus 2, it is actually less than this, less than this, less than this. This is our answer. Check the options now, which is correct. Among the options A, B, C, D, let us check where this particular answer is actually suitable. Scandium plus 2 is less than titanium plus 2, vanadium plus 2, chromium plus 2. See, this is the answer. Answer C is the correct for this. Next, coming to the question number 24. Which one of the following pairs can have almost equal atomic radius? See, observe the options given. Wherever 4D and 5D elements are there, recollect in the explanation. Wherever 4D and 5D element, 3D to 4D atomic radius increasing. 4D to 5D atomic radius has to increase, but we said 4D and 5D are having more or less same size because of lanthanide contraction effect, clearly there in the notes. Therefore, we can consider the answer niobium and tantalum. See, scandium and yttrium 3D 4D elements, niobium and tantalum 4D and 5D elements. Option C, copper and silver, again coming to be 3D and 4D elements. Option D, vanadium and manganese, both are belong to same 3D only. So what I said, 4D and 5D element wherever comes, those are having more or less identical this atomic radius. So option A, option B, C do you take? Given in the options, B option, this is what niobium 4D element, tantalum 5D element. Therefore, answer is the correct answer, option B. This is what the correct answer. Coming to question number 25, which of the following species is unlikely to exist? It's again one more interesting question. Before this, we have solved this type of questions. Two questions we have solved on vanadium. Zirconium is given here. See, where is the zirconium? What is the maximum possible oxidation for zirconium? Yes, zirconium maximum oxidation number coming to be +4. B, C, D options to take. Maximum oxidation number of zirconium is +4 only, should not exceed +4. The option A, ZrOCl2, O is -2, 2 chloride Cl -2. So in the option 1 you take +4, it is existing. Coming to B, ZrI4, 4I minus ions, yes, in this also it is +4. Coming to option C, ZrF6 -2. So inside is 6 minus charges, 2 charges are existing over the complex, yes, in this also +4. Coming to option D, ZrF8 -3. Look here, inside the bracket 8 charges, 8 fluorons. Outside the bracket -3. By this you can say zirconium is +5. What I said, maximum oxidation number possible for zirconium is only +4. But option D coming to be +5. So this is unlikely to exist. So answer is what D is the answer. Coming to the question number 26. Question number 26. See, lanthanide elements refers to. Even 10th class onwards, we go on studying this particular periodic table. The lanthanides, where we actually call lanthanides. Lanthanides, don't see the answers, let us say. Lanthanides starting from cerium 58 to lutetium 71. Cerium 58 to lutetium 71. So answer is the elements from atomic number 58 to lutetium 71. So for the question number 26, option A is the correct. You need not think much about it. Yes, answer A is the correct one. Coming to question number 27. Heavier rare earths are also called. Heavier rare earths also called. See, all the rare earths consider lanthanides. We are classifying into two sets. Lighter lanthanides, heavier lanthanides. Lighter rare earths, heavier rare earths. According to, based on their availability in different minerals. Following, based on the availability of lanthanides in different minerals, all the lanthanides are classified into two sets of elements. Now, take option A, B, C, D, let us keep it aside. Next, what I said, all the lanthanides classified into two sets. What are lanthanides? Look here, cerium to europium you take. Europium. This is what? 58 to, this is 62. And again consider gadolinium 63. 63 to this gadolinium 63 to, and you take lutetium 71. Lutetium 71. Cerium, praseodymium, neodymium, promethium, samarium, europium. Up to this particular cerium 58 to europium 63 it is. This is what 64. Gadolinium 64 to lutetium 71 you take. First half is actually lighter lanthanides, and second half actually heavier lanthanides. The lighter lanthanides are generally known as serrate group. This is known as serrate group of elements. And next second half of elements, heavier lanthanides, these are known as what? Yttrium group of elements. We call them as yttrium. But what is the question there? Heavier rare earths are also called as yttrium group. So answer is what? Answer coming to be B. Option B is the correct. Heavier rare earths yttrium, lighter rare earth cerite group. So this is the answer to this one. Coming to question number 28. The configuration of terbium plus 4 ion A, B, C, D. Consider the terbium configuration. Don't see the options now. Terbium configuration. Terbium configuration is, it is actually F8, D1, S2. F8, D1, S2. F8, D1, S2. This is the configuration of terbium. How many electrons lost? 4. 2 from S, 1 from D, and 1 from this particular 4 electrons. Therefore, the configuration should be, it is what? F7, D0, S0 should be the configuration. Then coming to the options, A, F0, D0, no. Option B is given as what? F7, D1, S0. Option C is given, it is what? 4F7, 5D0, 6S0. This is what? 6S0, 6S0, 5D0. So option C is the correct. So here answer C for question number 28. Question number 29. Praseodymium plus 3 is green in color. The ion with identical color will be. Here you have to remember all the 14 lanthanides should be in a position to put the table. Otherwise, you cannot answer this. While teaching also given, you have to remember all the 14 lanthanides. All the 14 lanthanides you have to put in the form of a table. Then only you can easily answer this type of question. This type of questions are in every entrance exam repeatedly coming. So, for lanthanides, color properties, and which pair of ions are having more or less identical color, this is very, very important. This question is more interesting, and this type of questions are repeatedly appearing on this lanthanides. Let us take first A, B, C, D. Don't see the answers. First you make out your answer. How to make out? You have to make a table here, otherwise difficult. Now, look here. Cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium. First write first 7 elements of lanthanides. Start with again gadolinium up to the last element to write. See now, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium. Like this, all the 14 lanthanides you have to make into 7 pairs. 7 pairs. How to check it? This particular pairs of elements. He has given actually plus 3 ion. Yes, put all plus 3s only. Plus 3. I make it all plus 3. Plus 3, plus 3, all plus 3 ions. Coming to next, here also plus 3. Plus 3 ions you made it. Then all these are definitely carrying same number of 100 electrons. Yes, this is 1, 2, 3, 4, 5, 6, 7. The pair whichever carrying same number of 100 electrons, the pair will be exhibiting more or less identical color. What is given? Pure plus 3. Pure plus 3 is having 200 electrons. Holmium plus 3. Pure plus 3 having what? 200 electrons. Thulium plus 3 also having what? 300 electrons. This pair is the correct pair. Therefore, praseodymium opposite to this what? Thulium plus 3. So, answer C. C is what is given. This is what? Thulium plus 3. So, here answer C is the correct. Next, coming to question number 30. Question number 30. See, neodymium plus 3 is reddish in color. The ion with the identical color will be. Neodymium plus 3 is given. So, option A, B, C, D. What is given? Neodymium plus 3 is given. Once again, let us make the table. Just now I shown to you. Right. Cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium. Again, you make the gadolinium to higher element. Gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium. Second time I am writing on the board. Just the previous question also more or less same concept of a question. Neodymium plus 3 is opposite to the what? Erbium. Therefore, here both of these are having same number of electron. This is 1 unpaired electron, 2 unpaired electron, 3 unpaired electron. Answer coming to be erbium. So what is the answer here? Erbium plus 3 is the correct option. So answer here is what? A is the answer. Neodymium, erbium plus 3 both are having same number of electrons. Their color is found to be more or less identical. This concept is very important. For this, you have to remember all the 14 lambda. You should be in a position to write this particular table. Otherwise, you cannot answer in the examination. Right.